Our next talk is from Yaroslav Halchenko, or Yarek, who will join us to talk about the DANDI archive. So this has been a really great development recently. DANDI has finally given a home to all of the precious NWB data sets, and much more than that. And not only a home, but a whole platform for collaboration. So Yarek, I'll pass the puck to you. I'm going to be in the breakout room doing office hours. Yeah, let me know. Shoot me a message if you need me. But I'll leave it in your capable hands.
Okay, thank you, Ben, and hi everyone. Maybe some of you heard me blabbling yesterday really fast through some slides, and today I could go slower. But maybe because I believe this is like more open session, right? So it's to meet with you and answer your questions. If you have any questions right away, please feel free to ask. If not, then I will continue with presentation, or start with presentation, and we'll try to answer your questions as they appear in the chat. Any immediate questions from anyone? No? Okie dokie. Let's get the presentation, present, and share the screen here. Presentation. Where is this one? I'll share my entire desktop, hopefully. No, something glorious will appear. And chat, though, I will not be able to see chat at the same point. So I'll talk about DANDI, which is a project funded by NIH to provide Brain Initiative archive for neurophysiological data. But we want to go beyond just providing an archive. And who is we? It's a collaborative effort between MIT, Dartmouth College, Kitware, and Catalyst Neuro, led by Ben, who just disappeared from the screen. And it's also supported through Amazon Web Services public dataset program. So they provide us free hosting for all data which gets uploaded into archive, all public data which gets uploaded to the archive. And we work tightly with collaborators, some of which are standard groups like Neurodata Without Borders, BITS community, but also with bigger initiatives like INCF, and also another data collection and harmonization portals and initiatives such as Brain Cell Data Center and Allen Institute and individual labs. So what is DANDI? DANDI is not just an archive, but an entire, web platform in the sense that there are components which live on the web, but it's not necessarily only website. We provide tools, we provide infrastructure, we provide archive. Where people could not only deposit data, but also collaborate and process data from neurophysiology experiments. To establish this collaboration, we rely on standards as to provide common language, how people could analyze data harmoniously. And one of those, of course, is Neural Data Without Borders, which provides you, as you have learned in the past days, a standard for how to encapsulate your data within a file for a session, right? Or maybe even for the same session, you could have multiple NWB files. But NWB itself know-how instructs you about how to organize the files on the hard drive within your data set. Not only for upload to DANDI specifically, but even for your own practice in the lab. And that's what brain imaging data structure format is about, how to organize individual data files and maybe supplementary metadata files into consistent hierarchy. That's why there is lots of kind of interaction between us using NWB and also bit standard. And bit standard itself does support NWB files. And we are working with BEPs, which is brain enhancement proposals, which when group sees that, oh, something needs to be enhanced within bit standard, such as, oh, support microscopy data or animal electrophysiology. We work also with those groups to facilitate, at least, if not to help, to establish this, to enrich bits to support additional data structures. And there is also neuroimaging data model, because some of the data which comes into a data, DANDI archive is imaging data, right? And for that, NIDM establishes much richer descriptor about of metadata about what was done, provenance tracking of what was done, and what parameters were used for specific neuroimaging acquisitions. So altogether, DANDI also aims to make both data and software for cellular neurophysiology fair. For that, it provides cloud platform for data storage, for collaboration, easy to use tools, and computational hub. So minimal in the sense that at the moment you cannot run months of computations for free on the hub. So it provides you kind of a gateway, but work in progress. So you could establish your own instances and just pay for compute. So in greater detail, if you don't know what FAIR is findable, accessible, and interoperable and reusable, which was established to describe data portals or archives and infrastructure, not necessarily data per se or software per se, but now you could hear FAIR data or FAIR software. But in principle, it's more about the infrastructure, which should be providing all capabilities to make work with data and software and whatnot more efficient and findable, accessible, interoperable, reusable. And as you could see from that description of what DANDI provides, it largely centers around standards and protocols. That's why we, of course, work tightly with NWB group to make sure that we use standards which are established or being established in the community, but also to facilitate accessibility and interoperability, right? But primarily accessibility. We are not just trying to narrow down, okay, you work with this data only this way, right? But we are trying actually to do the opposite. We're trying to make data as widely available and available through different means. Like we have API, we have DANDI Python clients, we have data-led way to fetch data. We also support read-only S3 virtual file driver, I believe, within HDF5. So you could load only the data which you need for your computer without downloading the entire file. And I want to introduce you to the term DANDI set, which is our way to say data set of DANDI, which comes as a collection of files with, or we call them assets, with associated metadata and also metadata to describe data set. So what data are there for you in DANDI? We cover a good number already of different modalities, and archive grew up quite a bit in the past year. As you could see, we host now over, so it's June 21st. Oh no, that was June 21st. My icon hides myself. We didn't put, now we have 42 terabytes. And number of DANDI sets is growing, and I hope that after this presentation, we'll get even more DANDI sets. So Ben yesterday gave a quick walkthrough through the archive, and I'll just show some screenshots through the talk, and later on I could walk you through again if there are any specific questions on how to use the web interface of the archive. But this website where you go to dandiarchive.org, which forwards you to GUI.dandiarchive.org, is only one component of the larger ecosystem. So what is there in ecosystem for collaboration? You have heard about NWB Explorer, so you could use NWB Explorer or Bioimage to view the data which is provided by DANDI archive, which all resides stored on Amazon S3 bucket. So everything in DANDI is centered around storage on S3. Or if you deploy your local instance, which we are not yet officially supporting, but the goal is to provide ability later on to install, let's say, your lab DANDI archive. So, and then make DANDI archives interoperate between each other. So you don't need to work in command line, but could seamlessly synchronize, let's say, data in your local archive and the DANDI archive. But so you could use MinIO to provide local S3-like storage, but at the moment, all the data is stored in Amazon. And another core piece of DANDI is the API server, which is more than just API. It's the backend server, which implements all the functionality for data management. Then the GUI, which you saw, which is that web client for DANDI archive. But you could use also Python clients or even use DataLad. If you haven't heard about it, I'll mention briefly later on, to get really nicely, tightly controlled Git data in Git.annex repositories, so you know exactly which version of data did you use at any point in time, and also seamlessly get and drop, that's DataLad and Git.annex term, data files as you need them or no longer need them. But also we provide the hub where you could do this minimal computation. So there is a ecosystem of web platforms and other tools which we provide to interoperate with DANDI archive. So let me go a little bit through details of every one of those components. So the API is, as I mentioned, the backend. It's the heart and the brains of the DANDI archive because it implements, it pumps all the data, it orchestrates all logistics of the data, right? How it gets uploaded, how it gets downloaded, but also validation of metadata as it gets uploaded. And one of the cute aspects of this infrastructure is that we are striving to achieve efficient data management through, let's say, deduplication, integrity verification. So it's, whenever data is uploaded, we verify that upload proceeded correctly and integrity in the archive or checksums in the archive are exactly the same as on your local hard drive. And the deduplication allows for various interesting scenarios where you could have multiple metadata sets, right? Where data would come from different data sets, but the actual data files would be the same, right? Let's say you could create a data set for a specific study instead of referencing all individual data sets. Also, you could create a limited view of a particular data set to provide easier access to a specific portion of it. Also, metadata is validated. I'll mention later on metadata schema library, where we define the schema for metadata. So whenever you upload the data, we validate that, oh, metadata is valid or not. And then if all metadata is valid for DANDI set, for all the assets, we allow publication of that DANDI set version. So what publication means is that we create a version of the DANDI set, which we guarantee that it will be immutable and it will persist through time. It's not the same as, let's say, with Git, right? So you have your master branch, go and you modify it, and you still have access to all the previous versions within the master. In DANDI, we cannot afford, let's say, keeping all the versions of the files. Let's say you're still working to achieve some released version, right? There is no guarantee that all the draft versions will be available. They're available at the moment through DataLad, but there will be no such guarantee in the long term. And for that, you need to publish data sets with specific version or obtain DOI, which could be used then in publications to reference your data set, and we will provide guarantee that that data will be available long term. And interface of this API, here I show not just API DANDI-archive.org, but if you add Swagger, you will go through to this interactive interface where you could play with API. Even it's kind of cool in a sense, even if you don't know what APIs are about, it gives you interactive user interface where you could do this kind of low-level interaction with the archive. And needless to say that it's really useful for if you want your tools to program and interact with the archive. And please pardon my chickens, they're making noise. So based on that backend, we have web UI, which you saw before, and it provides you various interfaces, such as navigate through available datasets, search them up, see metadata of the datasets, edit that metadata if you have access rights to edit it, and navigate individual files, or we call them assets, download them, see extended metadata for them. And even unlike Dropbox, we even show you the sizes all the way up to individual, or not individual, but folders. If you go to Dropbox, you sometimes don't know how much you have data in a specific folder. Our web UI provides you, although concise and limited, but really efficient, I would say, UI to navigate and figure out what those data sets contain. Okay, so that website is just a client which talks to that API server which I presented and allows you these basic operations. If you are into programming, some implementation detail, it's written in Vue.js framework, and all the sources are, everything in DANDI is open source, so you could find them online. And another cute part which will be mentioned also, that this web UI for editing metadata is driven by the schema itself. So it's not like it's really hard coded, but you modify the schema, web UI changes as well. So, and talking about the schema, one of the Python libraries, core Python library, is DANDI schema, which provides you pydantic models which describe all metadata for DANDI sets, for assets, for published DANDI sets. And from that description, we produce JSON LD representation and also JSON schema representation. And from that JSON schema representation, that's how this web UI view or edit metadata gets constructed. So if in your projects you want to easily create web UI for editing metadata, this provides a nice workflow for that. And another Python library and also command line interface is provided if you install DANDI. You could install it through pip install, or it's available also in Conda Forge channel. So the typical workflow, how do you work with data in DANDI, consists of first registering a dataset if you are to upload a new dataset. Then you register it on DANDI archive, and on DANDI archive you will use the web UI to edit metadata, which will provide you some assistance when do, undo, and validation at the end, either that metadata is valid. But if you start you could take any DANDI set and download it. So for downloading, you could use DANDI client and just type URL to that DANDI set, or you could use datalet and install them as Git annex repositories. But okay, if you create a new data set, the workflow, you register it, you get your API key, which later on you will use to upload the data. You could get it from the web UI. Then you organize your data into the DANDI archive. As I've mentioned, NWB itself doesn't anyhow instruct how you should organize NWB files. For DANDI, we are trying to make it more consistent and coherent and bits-like. We are not fully yet organizing it into bits standard, but we are working together with bits to eventually make it true. And we provide command, which is DANDI organize, which helps you, given collection of NWB files which you already have, it will load them up, extract metadata, basic metadata, session ID, either there is cell ID, and put that into the file name. And try to disambiguate if, let's say, multiple files were with the same minimal metadata and we didn't anyhow support for additional tags to include in the name, it will add some disambiguation tag. But the point is that altogether, you will get a consistent representation of data across all the DANDI sets. So if you go to DANDI archive and you look through DANDI sets, you'll see that they're all organized pretty much the same way. And that organization is not taken out of the blue. It somewhat mimics bits. We just didn't include session level for the next one, and we don't have all the top level README dataset description mandated at the moment. But in general, it bits like. and they will all look similar. And then you could validate those files. Validation verifies that they're valid according to NWB at the moment, and we are working to incorporate actually at this stage validation against DANDI schema itself, so you could ensure that all the files are valid when upload into the archive, although upload will do that too as well. After you prepared and validated the data, you go to proceed to upload, which is also easy. We have DANDI upload command. Within upload and even organize, I believe, and download, we try to take care to make it efficient. So we go multiple threads, multiple processes where it's needed to provide efficient upload and download. Okay, and then after it's uploaded, anybody could download this data. And then after you worked with your DANDI set, as you could see in this web shot, Web UI provides you information about what metadata might be incorrect or missing to get your data set published, right? So there are icons in the red, you click, you verify that, you see what's happening. You could fix them right away by modifying metadata of the DANDI set. If it's metadata of assets, you might need to re-upload the assets because assets metadata is automatically extracted from NWB files. So if something's wrong, it means that extraction failed, and or you used outdated DANDI tools, and you would need just to re-upload with a new version of DANDI and DANDI schema. But because you uploaded data before, we already have it in the archive, and this re-upload will be really efficient. It will just re-upload metadata and will not re-upload all the gigabytes of data. And then after you're done, this publish button will turn green, and you could publish a data set. So when you publish a data set, you get a new version added in the versions tab in the web UI, and also cite as dropdown will provide you DOI, which will also list it later on in the metadata viewer or data set landing page. We call this view in particular. So, and another interface which we provide for interaction with DANDI archive is data-led DANDI sets. All of those are regularly updated based on the data in the archive. So it's not like you uploaded the data and immediately those get updated. No, it happens like every hour. We are planning to make it more integrated within the archive, so those will be more immediately updated. But at the moment, this is a view to the archive as taken at hourly basis, and all those repositories are data-led data sets. If you are not familiar with data-led, we have an extended documentation in the handbook, and what it allows you is to really quickly, after you install data-led, or actually you don't even have to install data-led, these are purely Git repositories, so if you just want to view them down in your hard drive, and if any text file, it will be already in Git directly, you could immediately get access. But to get access to the data files, then you would need to install Git Annex and data-led, and then you could get or drop any individual file and use that as a part of bigger analysis workflow. For that, I would recommend you also to look into YODA principles, and YODA stands for Yoda's Organigram on Data Analysis. One of the students made a requirement, the name should be recursive definition. So YODA is like Unix, starts with itself. And we're, actually, let me show you. Here we go in the browser. If you go there, there is a poster from a few years back which depicts what's happening here. With this nesting of data sets using Git mechanisms such as Git submodule, you could create the hierarchy, which would allow you to organize all your digital artifacts, which could be data, which could be code, which could be entire containerized computational environments, either Docker images or Singularity images, in such a way that, let's say, paper data set, which could be used on its own, right? It would know which version of analysis data set it needs to install and from where. And if you care to see, oh, what analysis was performed on, then you install another sub data set. In this case, it's MRI preprocessed data set using fMRI prep. But if you're really interested to know even how that one came about, then you could install raw bits dataset. And even that one might lead you even to raw DICOM data. So while converting data for DANDI, because if you do conversion into the NWB, most likely it's not yet done at the hardware level, you might want to establish similar hierarchy of nicely, tightly version controlled data sets. And there is multiple other advantages of such organization. And then share corresponding, let's say, DANDI data set, which would be pretty much at the level of bits. But later, we also want to allow preprocessed data sets as reference and also regional data sets. So to establish this collection of data sets which have nice provenance on what they were based or derived from. Okay, let me get back to the slides. I don't need to jump. Oh, here we go. And another component is Jupyter Hub. So Jupyter Hub provides you this cloudy workspace, and every DANDI user or user of DANDI archive has ability to go and to Hub and choose the instance size in the cloud which you want to work on. And that instance would provide you Jupyter Notebook, of course, with all the Jupyter Notebook, right? So Jupyter Lab includes Jupyter Notebook, but also Shell in that instance, and as well the entire full GNU Linux desktop. So if you want to run some GUI application, you could quickly install it there and run it on the data which you download from the cloud. And this instance will be in the same zone as AWS bucket, so transfer would be efficient of the data into that instance. And if you're interested in how it was done, it's a Kubernetes deployment using Ansible and many nice features. And let us know if you want to know more. Again, all the materials, how it was established, they're available online. So altogether, I've mentioned already quite a few technologies which are out there, and all of them are open source. Pretty much in development of DANDI, I think we are not using any, well, we are using services which are not open source, but all the pieces of software which we are using for tools or for infrastructure, those are all open source. And we are trying to cater a wide variety of use cases, right? It could be from scientists, right, who did collection of data and then upload it to the archive, right? So who might interact with multiple components which we provide or which just exist outside. But also we trying to cater to software developers, right, which might want to primarily interact with our API server, right, and maybe work through data lab. But in general, wouldn't be interested in web UI. That's why also this modularity of components help to cater different audiences. But also we're working with hardware developers to assist or encourage conversion in or deposition of the data from the hardware directly into NWB files. So more information is available on the right and how you could reach us out. But again, all the sources are available on GitHub under DANDI organization. Don't remember what, that's what I was spelled out without going through animations. And what is our roadmap for next 3 years is, first of all, to improve search. We've collected good amount of metadata. Now we want to provide more convenient or more elaborate search capabilities in the archive, and also provide embargo support. At the moment, all the data, as soon as you upload it, becomes publicly available from the public S3 bucket. We cannot deposit data in the public S3 bucket sponsored by AWS if it's not public. So we need to figure out how to orchestrate the position of data, which will be embargoed for some period of time until you're ready to publish it, or maybe that embargo period reached. We are still discussing what should be the period of embargo. And then, as I've mentioned, to establish deposition and assignment between raw and processed data and collection of this provenance, right? So this data was produced from this data using this activity. And work on local deployment. As I've mentioned, in an ideal world, every lab might have their own DANDI archive, and that data could then seamlessly be synchronized to the mothership archive us, right, or any other maybe lab which it could get connected to. So to establish this DANDI federation, right? Okay, and I think that's it. I hope that I provided sufficient amount of information for encouraging your questions about DANDI and how to work with it. Okay, everybody is asleep or nobody has questions? Then I could talk until someone interrupts me. Join a breakout. Check. Okay, let's check who is still not asleep. If you deposited data already, or let's say if you interacted with the DANDI archive to any degree, would you be so kind to raise your hand in the list of attendees? Okay, Ryan interacted, that's good. So we have 3 people, okay. Who, okay, please lower your hand. Oh, there is Dorota now interacted. Okay, so we have about 4 or 5 people. Who is planning to deposit some electrophysiology data into the DANDI archive? Please raise your hand. Okay, so we are getting about also 4 people. That's good. I hope that we made it more or less easy for deposition. And if anything, we have, so when you register a DANDI archive, I believe you are sent email with invitation to Slack channel. So please join us there and ask any questions. There is even, I believe, debug room where you could state the problems and we'll try to help you to rule them out so upload goes smoothly.
Hi, could I just ask, I missed the first half of your presentation. I was in one of the breakout rooms. Where does this video get uploaded afterward? Because I'd like to watch it again. Do you know?
Were the talks uploaded? I
Yes.
don't know. Probably Ryan could help us.
Yeah, I think it gets uploaded to the INCF.
The training
Brella,
space?
yeah, the training space, the Brella platform for this workshop.
Okay.
But if you want, I could just go again through it.
I wouldn't make you do that.
Right, okay. So for upload, if you have any trouble, get in touch with us. We'll straighten it out. Meanwhile, I could just then blurb for the next 25 minutes and demonstrate some of DANDI and maybe some of DataLab as well, or those DataLab datasets. Let me share my screen again. Okay, these were the slides. And if we go to dandiarchive.org, this will be in the way. Okay, so you've seen this page, and Laurel, I believe it's your microphone, which is a little bit
Sorry.
noisier than me. So public data sets, DANDI sets provides you a view of all public data which is available, all DANDI sets which are available on this, and they are sorted by default that the latest modified are on top. but you could resort it that the oldest ones would be on top, and by identifier, if it might be easier, or by the name, which I'm not sure how useful that is because names usually arbitrary. We don't mandate how a name should be structured. Or the easiest might be to go and try to search up some specific data sets, right? So 29, let's say. So this is a data set, which is just a test data set. There is no interesting data in there, and it has got a number of releases. One tricky point, if you end up in your data set and you didn't see publish button, it means that you are in the version release and you need to go to draft, and that's when publish happens. Is possible. In my case, it's green. You don't see any red signs. It means that all the files have, and DANDI set itself has correct metadata. One of the features while you're in the draft, unlike if you're in the version, right, you could see that in the released version, you could only view metadata. So you cannot edit it. Once again, we promise that it will be persistent, immutable. So releases must not change. So you could only view data and metadata. But in the draft version, you could go and modify data or metadata. Actually, you could modify data by removing files. Every file here has delete button. If you want to delete more than just one file but a folder, you could use DANDI client and specify which folder you want to delete, and it will remove it using interaction with API server. So edit metadata gives you really nice web UI to edit various aspects of the data set, right? So you could go select what are we adding here and that to me, right? And provide which identifier, uniform identifier, where that one comes from. Identifier can be any URL or compact URI, preferably supported by identifiers.org. So here we should probably provide you additional references where to find this Uberon ontology, but Google is always a savior, right? So you could go and find for specific anatomical term from Uber over there on that website. Okay, so this is Web UI, which provides you ability to modify, and you could see that you could undo or redo and eventually save if anything gets changed. Let's get back from this one. You could cite even a draft version of a dataset, but you could see here that the will have a DOI at the bottom. They should have DOI at the bottom. For some reason, this one probably was published before we fixed some bug. I didn't see it here, but it should be there. But also you have perma link to this data set, which will go to specific version of it, not just draft. Well, I'll figure it out later. Okay, what else we provide here? View metadata will be similar to how edit looks like. It just you will not be able to modify anything. You can just view the metadata which is available there. And this is not the best data set I've chosen probably to demonstrate. Let's check out the most recent released one, 54, right? This one will provide you with a better example of what metadata could look like, right? All the contributors could be referenced and later on, I hope, included in citation. There we go. And it has DOI.org URL. So everything worked out on this one nicely. Okay. And then I've mentioned you all the glorious DANDI sets of DANDI. So this is a super data set which points to specific versions of each individual DANDI set, which otherwise live in this organization on GitHub. So you can see we provide already some summary about how much data in there, and even releases should be noted later on, how many releases that DANDI set has. So now I'm entering DANDI set, which has 3 terabytes of data contained in 54 files. Let's say you decided to explore it locally on your hard drive, and that's what Data Lab and Gitanex make it easy for you. So let's say if I say clone GitHub DANDI sets 59, within few seconds I am getting Git repository, right, in which I have already tagged for specific release. Now I'm in the draft branch, which is nicely aligned to having a draft in DANDI archive itself, right? And it was so quick, not through magic, that 3 terabytes somehow leaked or went through hyperspace to my laptop. But how Gitanex works, every file is replaced with a symlink. Every data file is replaced with a symlink, and symlink itself is really lightweight. And then Gitanex keeps track of where every such symlink is available from. So this one in particular, it knows that it's available from S3 via one of those URLs, right? It could be, actually, this one is not S3, this is our API server endpoint, and this one is S3 endpoint. And this one is quite sizable, right? So probably if I start to get it, I will not wait for 39, and download failed. That should not happen. But meanwhile, it's complaining about downloading it. So that's good, but I'll check what's happening in here. So you could get any file fetched to your hard drive from S3. Let me get maybe a smaller data set on which it might be easier to demonstrate these features of Data Lab. So if I go now to this test data set, which I had shown, right, which has just a few data files which were copied from other data sets. And let's say we go to this one. So this one is quite boring one. It's a test file from NWB, PyNWB itself. But here's we are by some file which comes from a real study, and I could request and get it. It's still complaining. I need to figure out what's up with that error. But meanwhile, it's still fetching. Okay, so now that file is available locally. So I could use, even if I install DANDI, let me just enable, do I have DANDI installed system-wide? I don't, right? So let me enable virtual environment in which I develop DANDI client, master. Okay, so now I have some version of DANDI client. Every version is nicely versioned. And I could use, let's say, DANDI ls command, which allows me to see some metadata which gets loaded or extracted from NWB file. It's not exhaustive metadata record, but it provides already some information, about institution and keywords, whatever we can harvest from NWB file. If I fetch multiple files, let's go, I don't know how many there will be altogether, but DataLab supports also parallel download. In this case, again, ignore that message. But you could see that it fetches in parallel multiple files, which are not too many, just 14 megabytes. And what I wanted to demonstrate that this ls, although maybe I would need to make it all smaller, could be used on multiple files, and then it will switch, well, unless it fails. Oh, I didn't specify ANM, right? And then NWB. Yeah, I misspecified something. Then DLS, all those files. It will provide by default then tabular view. So you could sometimes more easily see what differs. In this case, they're kind of the same, besides subject ID is different. But also you could manipulate and say in which format you want it. Actually, let's check help. Help. Okay, So you could specify which fields to display, but also you could just say which format to use. Let's say it could be JSON pre-printed or JSON lines where each record will be a separate line. And then you'll get that alternative representation of that metadata. These commands could also be used on remote data sets. Let's say if I have this URL, of course, because I'm given live demo, things might just break. But let's be hopeful, and I'll give it a URL which points to the archive. And what happened, it downloaded metadata of the archive itself, right? So this is metadata of the archive itself. And if we look into help again, we could say, okay, recursive to DANDI set, blah, 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 but also metadata either for all, which will actually be, it's not just API, it will be DANDI set, I believe, or assets. Let's try now to list all the assets. If you don't like web UI, you could use this ls to quickly see what is on their archive. Metadata, hold on, metadata assets, and that was part of the list. Here we go. It really doesn't want to show me assets. It still shows me, let's do all. Maybe because I didn't put this one. Yeah, live demos are tricky. I need to figure out what's broken with this too. But the idea is that it should provide you with listing of specific assets and their metadata, even from remote location, but also works on the local files. Okay. And now, after I, let's say, worked with some files with datalet, now to save precious megabytes of space, I could drop those files and like I never got them, but still have this Git repository history, right, about modifications and whatnot. Let's say if I fire up standard git k, which is a tool shipped with Git to navigate through the history, you could see that this, how that data set evolved through time, and you should be able even to access previous versions or specific tags for that version, right? In this case, this data set had multiple tags, so I could quickly check out specific version of the data set. It still says tag, so here we go. And then get those versions of the files, which were, like you noticed, maybe that 123 dat now is here, which wasn't there before. So with Git, you could have full history of data sets. And if you manage data locally, with datalet, you could still use DANDI upload to upload data files or DANDI set, modified data set into DANDI archive. Okay. I wonder if any questions at this point. Let me stop share and check out the chat. Okay, no questions. I gave such a clear presentation, a really boring one. Ryan Lee is talking, but I cannot hear anybody. Gee. Could someone talk to me now? I don't know, maybe my headphones.
Do you hear me?
Yes, now I can hear you.
All right. I don't have any questions. I just helping you confirm that you can hear.
Oh, good. Okay, at least that. It just, these headphones, sometimes they fall off connection, and I don't even know if there is no auditory feedback. Do they work or not? Okay. Then we could conclude earlier, or I could talk more. Ben must have questions, although he became data approved by now, I bet.
I've been using it. I've been using it to build continuous integration patterns where we pull example data sets and then test against them. Found it useful there. So
yeah, that's what it's useful for as well, right? So you keep everything. Let's say there is Gin, right, website where you probably host data, which is free hosting in Europe. That's why sometimes it gets longer to fetch it back to the United States, right? And then put into your continuous integration, get this data set. And the beauty is that you saw those errors when I did get. Most likely it's failed it to get from one URL. And you saw that there were multiple. One of them was API and another one was directly to S3. And my fear is that one of them is not working. And then Gitanix provides you this redundancy, right? It fails to get from one, it will get it from another. Moreover, you could establish different remotes. It doesn't need to go public. You could have your data set accessible to you through SSH, right? Or you could even deposit data encrypted into S3. So on S3, you would get data encrypted, and then Gitanix would de-encrypt locally whenever you or your collaborators whom you authorized to access that data, right? So there is various schemes of how you could use Gitanix to orchestrate this data flow. Let's say the entire archive of all those DANDI sets is also uploaded to Dropbox at the moment, because we have presumably unlimited Dropbox, and I'm testing how unlimited it is at Dartmouth. Just uploading the entire archive as yet another backup of the data, right? And it makes it really easy. You just establish yet another remote and say, push data there. Okay, what should I preach next about?
Well, I was in the breakout room, so I didn't see all of this, but did you cover DANDI Hub?
DANDI Hub, I didn't go to DANDI Hub. I just showed that it's there, but that's a good question. Let's go to DANDI Hub, although I haven't been there for a while. Let's see how our hub feels. We used to have a link on every DANDI set page, but I think it's no longer there.
No, it's just hub. Yeah, it's just hub.dandiarchive.org.
Yeah, I'll just type it. dandiarchive.org. When you go to hub, as I've mentioned, it gives you options to choose which of the instances with how much memory, and they all cost differently, and that's why if you just play around and also save your time to not wait for it to start, I would recommend Tiny, right? I think it should be sufficient for our purposes now, but if you want to do some analysis really, then you choose larger or extra large. Let's go with Tiny. For our means and purposes, probably it will be the same. And what's happening, it starts an entire instance with Docker container running the Jupyter lab just for you, with some notebooks already pre-installed, and I believe data-led DANDI sets also available, so you could quickly get the data that way. Okay. See, so for Tiny, even it takes a few minutes. For larger instances, it might take even a little bit longer to fire up. But after it's fired up, it becomes really convenient throwaway or not throwaway environment in which it would work. Right, so Python, that's okay. And I guess maybe it persisted from my attempts before when I was trying to install Brave within desktop here. So apparently there is persistence, and my materials persisted from the previous session. Hopefully I didn't do anything bad here. And DANDI sets, I wonder if I installed them on or they were here. Anyway, they're not. So where do we find all available applications? I keep forgetting about that. Run. Ben, do you remember interface which shows me all the, maybe they, no.
Oh, yeah, file, like file launcher, I think.
Ah, okay. New launch. Here we go. Yeah, launcher is just yet another tab. Yeah, I forgot about that. So this could be your primary interface to start a new kernel or go to terminal, right? Or where's my desktop? Did I fire up? It was some odd icon. Desktop, here we go. It's D. I was looking for monitor. Okay, so if you click on desktop, although this is tiny instance, so it doesn't have that much memory or CPU, but even in that tiny instance, you get full-featured Linux, GNU Linux environments, right? So, and some tools are available, or maybe not available. No, it's available, right? It's just not configured for your Git right? And now where do I have my, I should have given all demonstrations in here instead of instead of local terminal, right? So this is exactly the same super data set which I showed you available on GitHub, and I could go, let's say, to any particular DANDI set which is not installed by default, but then I could say data-led install this data set, and it will go git clone it from GitHub, and eventually, there we go. It just keeps complaining that it doesn't know about me. Git loves to know who you are. Email, I am Yarik. I am Yarik at gmail.com. Git know how verifies that they're legit, right? So it will be just that. Name Yarik. So now it should be more resistant to complain, and hopefully speeds would be faster than to my laptop. So let's see if I can fetch any data. 2 terabytes. Probably I don't have enough space here. The same error happens. We'll figure that out. But you could see that the speed is a little bit better than my laptop. It goes at about 20 megabytes per second now. Should have updated this one as well, the total. But still, with sizes as 2.5 terabytes, it might take a while. That's why there is this ROS3 driver. Ben, do you remember if our default one is having any? Oh, come on! It doesn't want to die even.
Yeah, it should. It should have ROS3.
Let's see if I could just kill it. Yeah. Okay, now how do I exit this wonderful desktop? Log out. And log out. Disconnected. Send control alt. Uh-oh. Let's do. No. I'm afraid to send control alt. How do I get back? Oh, right. It's separate tab. I still have it, right? So probably what should have sufficed is just to close the tab in here. Okay, so in terminal, if I open terminal, I could probably verify that it's not busy, right? So it's not running any other stuff. And where do we have our sample notebooks? If we go DANDI notebooks. 14 days ago, it was updated. Demo, let's say this is NWB widgets demo, which I've showed in the slides. And hopefully they all work, right? And this one is already crafted, right, to access data directly from S3 via ROS3 driver. As you can see, Ben was kind to point to the total size of that file, which is 30 gigabytes. I'm going to change that. And let's see how long it will take to load that NWB file. Let me make maybe this font a little bit bigger. So we are using here read-only S3, ROS3 mode, in which it loads only the data from S3, which is necessary to perform specific action. In this case, we just opened it and fired up NWB widget, which inspects metadata at first, right? Unless you go to specific tab, which could show you data, right? It wouldn't need to download it. And Ben could correct me if I'm wrong. And now you could navigate, and probably now when it needs more data, it will go and query it from S3. So again, we avoided download of all 30 terabytes and navigate in that file directly in, let's say if I switch to another one, maybe it will take again a little bit of time because you need to fetch it. But here we go. So 30 gigabyte file, we navigate online. What is this demo?
All right.
Here we go.
Well, you're in your final minute.
Yeah, and thanks everyone for your attention. I hope that you will use DANDI, even if you didn't like my presentation.